Hi, I'm Bob Warfield from CNC Cookbook. Today I want to talk about conventional versus climb milling. Which one is right? Most of us do one or the other and seldom change. If we're manual machining, we always use conventional milling. If we're CNCers, we always use climb milling. But is that always right? It usually is for manual machinists, but things are far more subtle for CNCers. Let's get a quick refresher on which is which. I like to use this diagram. Imagine the workpiece is moving and the spindle is really a pinch roller. Ask yourself whether the pinch roller is helping to move the workpiece in the direction of feed or whether it's fighting that motion. If it's helping, then we're climb milling. If it's fighting the feed, then we're conventional milling, and that's an easy way to remember which is which. Okay, so why are CNC machinists so fond of climb milling? The reasons are pretty simple. Refer to Datron's handy diagram at right to visualize what's happening. First, the chip starts thin as the edge hits the cut at the top. The piece continues to feed and the chip gets fatter at the bottom because more's been fed. This thin to fat shape traps heat in the chip. You've probably heard that proper feeds and speeds carry the heat away in the chips, and this is why. Second, cutting forces are lower when climb milling. This can lead to less deflection, although things get complicated with deflection, as we'll see shortly. Lastly, look at the diagram again. The chips get spit out the back when we're climb milling, away from the cut. They're less likely to be recut. Imagine the cutter was rotating as shown, but the cut was moving in the opposite direction, right to left. Chips in that case are getting thrown straight up, which may result in more recutting of the chips. These things all combine to result in longer tool life and better surface finish when you're climb milling, at least most of the time. There's just one tragic flaw, and it's the reason manual machinists don't climb mill. Recall that pinch roller idea. The pinch roller is trying to pull the cutter deeper into the cut. If there's backlash in the machine, though, the cutter can actually suck the workpiece into the cut. Aside from this being dangerous, you'll often break the cutter, and it certainly isn't happy for tool life or surface finish. So we just don't climb mill on manual machines because they usually have a fair amount of backlash. Okay, CNCers, so then it's clear, should you always climb mill? The answer is no. Considering this interesting case, it concerns the width of cut or step over. If you're cutting less than half the cutter's diameter, climb milling wins. From half to 3/4, it really doesn't matter if you're doing climb or conventional milling. But if you're cutting more than 3/4 of the cutter's diameter, the climb milling will transform your cutter's positive rake geometry into negative rake. Not good. If nothing else, most cutters are designed to operate with positive rake. You can intuitively see from the diagram that negative rake is going to increase the cutting force because the tool is dragging across the workpiece instead of cleanly slicing it off. It's pretty hard to remember this rule, so I actually built a warning for it into my GWizard Feeds and Speeds calculator, which you see at the bottom, just so I didn't have to keep track of it. Surface finish. Here's another odd effect that few machinists are aware of. It will affect your surface finish when making your finishing cuts. The diagram has arrows showing the direction and magnitude of tool deflection for both climb milling at the bottom and conventional milling at the top. Remember, in both cases, the cutter is moving left to right. It's just a question of which side the wall is on. Note that the arrows for climb milling tend to deflect forward into the cut. The tool takes a bigger bite, and this can result in wavy walls on your cut. By the way, it can also cause chatter on heavier cuts if there's enough deflection. But when we're conventional milling, the tool pulls back from the cut. This means that sometimes conventional milling gives a better finish with no wavy walls compared to climb milling. but you can't be sure. The arrows are also shorter for climb milling than conventional, which means there's less cutting force with the climb milling. So this effect is not predictable ahead of time. It's something you have to try out on a case-by-case basis. I hope you can see that CNCers shouldn't automatically choose climb milling in every case. It's right for most cases, but not all. I'm Bob Warfield. Thanks for listening, and I'll be back soon with another CNC Chef video.